Hey guys, this is gonna be the first video series, first video I actually make ever. Just picked up a new drawing tablet at Best Buy today. That was a real nightmare. I'm not going to Best Buy. But yeah, this is gonna be a dynamic programming video. I'm on AtCoder's website right now. This is the Ron page. Oh my god. A lot of tabs. This is, yeah, if you just Google educational DP contest, you can find it. So, I'm not going to post the link in the description. I don't know, maybe if I get sponsored, I will. Just, subtle cue there. Anyways, let's get to it. First question we're gonna do is called Frog 1. Basically, you have a frog, and he just starts on a stone here. Always starts on stone 1, and at each step he can jump either 1 or 2 steps. So from stone 1 he can get to stone 2 or 3, and from stone 2 he can get to stone 3 or 4. Alright, so let's get to it. Here's a test case here. Example input is n, which is the number of stones, and then it's the cost associated with each stone. So, yep, costs are calculated by, say if you jump from stone I to stone j, then it's h of I minus h of j, right? Say you jump from 1 to 3, it'll be h of 1 minus h of 3. And here are h values here. And sample input here, test case of 4, and h is 10, 30, 40, 20. That makes 4 stones. It says the minimum path here is 1 to 2, and then from 2 to 4, which is totally correct, because you can either take 1 or 2 hops at each time. So the minimum would be 1 to 2, which is 1 hop, and then 2 to 4, which is 2 hops. So a lot of times what I like to do with dynamic programming questions is, or just like contests in general, because my attention span is so short, I never really finish reading the question. I just try to, I don't know, see the test case, write out what I think could be a solution. So let's go to our whiteboard. Smooth draw. Okay. So our test case here is 4, and it's 10, 30, 40, and 20. And we're just gonna, for my program, which I'll do in a bit here, I am just going to declare this into an array. You know, I'm gonna, because our input here is these 4 numbers, or these n numbers, I'm just gonna put these in an array, and we'll call this array nums. Okay, and let's see. This is basically stone 1, 2, 3, and 4, right? You know, from stone 1 we can either go to 2, or from 1 we can go to 3. And then say we go to 2 here. Okay, then 1 to 2 cost would be 10 minus 30, right? Because cost, as given in the problem, is absolute value of h of I minus h of j, where j is stone landed on. So here, it's, if you go from 1 to 2, it's the absolute value of 10 minus 30, or 1 to 3, absolute value of 10 minus 40. That's 20 versus 30. Obviously 20 is in your minimum cost here, right? And the idea is we can just do this for every step, right? Say we're in stone 2, then we can either decide to go to 3 or 4, right? And we just repeat this process. If I want to go to stone 3, it'd be 30 minus 40. If I want to go to stone 4, it'd be 30 minus 20, right? Turns out the optimal path for this is 1 to 2 to 4, right? And that's 20, which is the cost of being at index 2, plus 30 minus 20, right? Which is the cost of jumping from 2 to 4. And so from here you can, like, I don't know, kind of get an idea. And because it's a dynamic programming contest, you can kind of notice that we should declare a DP array where each index has where each index represents minimum cost. Okay, like that's just what we need to do here. And this is really common in a lot of dynamic programming questions. You just want to declare an auxiliary array or a DP array where you store like your optimized value. And usually your array will store whatever you're trying to optimize, but not at the end index. It's just at continuous steps. And I'll explain more of that with this array here. You gotta draw always one less line to get to the number you want. That's the hardest part. Maybe. Anyways, so what we're saying is DP. This is our DP array, by the way. Okay. DP sub I equals minimum cost to reach ith index. And let's just think, okay, basically if you say you're here, right, say we're here, we could reach this position, which is stone 3, okay, by either jumping from stone 1 or jumping from stone 2, right? And that's the only ways we can get there, because the frog can only jump 1 or 2 steps. Just keep that in mind, okay? Delete that. Okay, so we want to jump. We just want to fill out this array first, okay? To reach the first stone, yeah, my handwriting's not the best. Probably because I have arthritis. I don't know if that's, no, it was just always bad. Anyways, to reach the first stone, cost is 0, right? And because frog starts at stone 1, right? So yeah, I'm labeled stones again. This is stone. S is for stone. 1, 2, 3, 4. To reach the first stone, it doesn't cost anything because the frog already starts there. You know, we can't. You know, so that's why DP of 0, because arrays are 0 indexed, by the way. So that's why this is DP 0. So I'm just gonna write this here. DP of 0 would equal 1, or would equal 0, because there's no cost associated with reaching the first stone or the 0th index, because we already start there. Now to reach the second stone, right, we can only take 1 to 2. 1 to 2 only path to stone 2. Now it's the only path, so to reach index 2, write DP of 1, minimum cost, reach the first index, or I'm right I plus 1th stone. Okay, just to make this extra clear here. That's gonna be right? 1 to 2, the minimum is always just going to be, because that's the only way you reach it, it's just going to be nums. So it's just going to be stone 2 minus stone 1. So it's going to be h of 2 minus h of 1, which in this case here is 30 minus 10, right? Which, yeah, so 30 minus 10, as we can see here, because we have to subtract h of 1 minus h of 0, or stone 2 minus stone 1. So so dp of 1 is going to be the value of 20. Just gonna erase some stuff here because I don't really know how to do the rest without any extra canvas space. This is the free version. Yeah, I don't know why this eraser is there a fucking hard eraser? This is a soft eraser. Okay, you know what? Hold on. Here we are. Okay. You know, I think, yeah, that's fine. Yeah, but our key takeaway still is dp sub I equals the minimum cost to reach the ith index, or I plus 1th stone. And we see that dp, okay, I'm still on erase. Alright, here we go. And we see dp sub 1 equals nums sub 1 minus nums sub 0. Okay, so now that we've filled out the first 2 spots in our array, we can finally get back to what I was saying initially about you can reach a stone from either 1 step or 2 steps back, right? So to reach 3, you could go from 1 to 3 or 2 to 3, right? And we just want to minimize the cost to get to 3, really, right? So really the cost in this case to reach index 3 would be, oh god. Alright, just had some production difficulties there. Oh, yes. Alright, anyways. Alright, where are we? Yeah, so to reach 1 to 3, to reach 3, you can either go from position 1 or position 2, because the frog either takes 1 or 2 steps, right? So yeah, so cost to reach ith index, right? Ith index dp sub I. Well, how do we find it? You know, how are we gonna find this? Just thinking out loud here, it's gonna be the cost to reach the equals cost to reach I minus 1th index, and that's, you know, 2 jumps. I'm sorry, that's just 1 jump. 1 jump plus the difference, right? The difference of index I minus 1, and yeah, so plus the difference, so which is absolute value of nums sub I minus 1 minus nums sub I versus the cost to reach I minus 2th I minus 2th index plus nums sub I minus 2 minus I num sub I, and we're gonna absolute value this, because it's basically at the end when you do dynamic programming, you just want to reduce everything down to recurrence relation, right? And we're just gonna compare these two and find the minimum. Well, let me write this out nicer. Okay, dp sub I equal minimum of dp sub I minus 1 plus abs, just little, I don't know, getting a little pseudocodey, nums sub I minus 1 minus nums sub I. That's a minus sign. And dp of I minus 2 plus abs of nums sub I minus 2 minus nums sub I. And if we fill out this array here, we're using this recurrence, let's see what we get. Okay. So that means dp of 3, or index. I'll write index, I for index, capital I for index, because in high level programming languages, again, arrays are 0 index. So this is index 0, 1, 2, and 3. So index 2 here, that'd be this box. That equals minimum of dp of 1. I'm sorry, dp of, here, I'll write this down. So dp of 2, index 2 equals minimum of dp of 1 plus absolute value of nums sub 1 minus nums sub 2 and dp of 0 plus absolute value of nums sub 0 minus nums sub 2. Alright, and let's check this out. Yeah, I mean dp1 we can see is 20, so it's going to be, this is a minimum of the first row here. That's 20. Well, I'm just saying this is the equivalent of the first row here. That's what I'm doing. So that's dp1 is 20 plus num sub 1 minus num sub 2. This is index 1, index 2. That'll be 10, right? It'd be 30 minus 40, which is 10. And this would be dp of 0, which is, just 0 minus num sub 2, which is, it's 10 minus 40 here. So it'll be 0 plus absolute value of 10 minus 40. And that equals 30. So really in both cases here, this is 30. The minimum cost reached index 3 is 30. Okay. We're gonna have to get out our hard eraser again. Not this limp stuff. Alright, okay, see, I don't want to erase my recurrence relation. I'm gonna rewrite this 30 here. Okay, that's a big O. Yeah. Yep. Just gonna finish erasing. Yeah, I mean, I think invisible pens are cool. Very Spy Kidsy. I like that. Okay. DP sub 3, which is index 3. Right. Fuck, it's still on erase. Okay. Yep, here we go. I'm just gonna write this with my mouse, which actually isn't that much worse. That is a testament to my handwriting. Not great. That's easier to do this. Bought the tablet, Alright, minimum of dp sub. What's 3 minus 1? 2. Yeah, it's 2. Plus abs of nums sub 2 minus nums sub 3 and dp of 1 plus absolute value of nums sub 1. Oh fuck, it's 4. I mean, oh geez, it's 4. Yup, I am still on. I'm not on adult only content right now. Didn't put the 18-year-old restriction in this video. Yeah. Yeah, nums sub. No, I'm sorry, it's 3. It's 3, yeah, Razor 0 next. It's 3. yeah, cause look, just follow the formula here. All right, dp of I is 3, index 3, 0, 1, 2, 3, 3, 3. Okay, that's just, yeah, this is right. I was just being a little stupid just now. Anyways, dp of 2 is just 20, right? It's 20 plus index 2 minus index 3, 40 minus 20, which is 20. And fuck this up. That's the regular relation. Okay. dp sub 1 is 20 plus num sub 1. Okay. Num sub 1 is 30 plus minus 20. Okay. Num sub 1 minus num sub 3. Look, this is stones, but really this is index 1, 2, 3, right? Like, I'm sorry if that's confusing. Just remember arrays are 0 indexed. I'm sure if you're watching this, you already know that. Yeah, so num sub 1, that's 30. And num sub 3 is 20. So 20 plus the absolute value 30 minus 20 equals 30. So really this reduces down to min of 40 and 30, which is 30. And so your minimum cost to reach index 4 is 30. Right? We're just okay. Honestly, the key takeaway here is just this recurrence relation right here. Oh yeah. Okay. And what I'm gonna do now for you guys is I'm just gonna write some code for this. I'll be using C++. I'm super shit at C++. I just figured I'd try something new. Alright, your inputs n while n minus that's just like my equivalent. That's just an equivalent of a for loop. Like you could write for it's I equals 0, I less than n, I plus plus, but this is faster and it looks more professional. I don't know. Anyways, so yeah, we're reading this n array. So, but we also want to declare a nums array, like I said. Nums array of size n, and well, n minus minus int h, c and h num sub. Okay, actually, in this case, we want to do a for loop. I'm sorry, yeah. See, gotcha. Keeping the viewers on their toes. But no, you actually want to do a for loop in this case because, see, if I did a while loop, that'd run for the correct number of iterations, but it wouldn't like set the values to the array correctly because n would be the value like 6 or whatever, right? Anyways, you'll see in a bit here. So num sub I. Okay, int h cn h num sub I equals h. Cool. And then, like I said, we want to declare a new dp array too, also of size n. And we want, like I said, yeah, right, dp of 0 equals 0 and dp of 1 equals num sub 1 minus num sub 0. I'm going to reiterate this, dp of 0 is 0 because to reach the 0th index or the first stone, there's no cost. You just start there. But the only way to reach the first index by 1 or 2 jumps is by just jumping once. So it's going to be nums it's going to be the cost at stone 1 minus the cost at stone 0, which is num sub 1 minus num sub 0. Yeah, so dp sub 0 equals 0, dp sub 1 equals 1, equals nums sub 1 minus nums sub 0. Okay, and then we want to do for int I equals 2, right? Because we filled out the first two indices of our DP array. We want to fill out the rest. I is less than n, I plus plus. Let's see. Yep, you're going to see our recurrence station now. So dp sub I equals the minimum of, I'll just do this, int x equals dp sub I minus 1 plus absolute value of num sub I minus 1 minus num sub I, and int y equals dp of I minus 2 plus absolute value num sub I minus 2 minus num sub I. And so, like I said in our recurrence relation, alright, we just want to pick the minimum of these two values. And then we want to return the very last index, or stone minus 1, right? Because stones are just indexes plus 1. So dp sub counts dp sub I minus 1. Okay, let's run it. Why is that? Oh yes, sorry, n minus 1, n minus 1. That's the number of stones you have. So, all right, sample input here. Let's try it. Gives us 30. Sample input here. 0, which is what we wanted, and then other sample input here. 20. What the fuck? Alright guys, a little something wrong with my code here. One sec. Okay. One sec, guys. Yup, so figured I was wrong with my code here. It's abs. I have to do the absolute value of this too, or else it just won't run correctly, because the costs are all positive, right? And I had a negative cost if I did that input. Let's try again. 40. Boom. Cool. Yeah, we're just gonna copy paste this, and we'll just hit submit, see what happens. Accepted, and we used 7 less bytes than last time. Yeah, this is it for the first tutorial. Let me know if you guys want some more in the future. Be sure to like, comment, subscribe, donate. Maybe one day I'll have my Patreon. Yeah. Alright, see you guys in the next one.